Okay, so we've offered some interpretation here of our C3. One of the interesting points to note here, if we take the sum of the 1,272, the 37, the 479, the 48, take each of these numbers and add them together, then that would produce, if we go back to our Rstudio, that would produce 2,380 total figures, right? So we have to explain each application and explain it in terms of whether the individual is successful in their mortgage application or not. But the total number of applicants, when we sum each of the buckets here, would be equal to, if we take each of these, and they would equal that 2,380, the full data set, the full number of applications or applicants for mortgage approval. Halvarian also offers some interpretation. So an economic example using the Home Mortgage Disclosure Act data, Manel, Tuttle, Brown, McAnany, 1996 examined mortgage lending in Boston to see if race played a significant role in determining who was approved for a mortgage. The primary econometric technique was logistic regression, where race was included as one of the predictors. The coefficient on race showed a statistically significant negative impact on probability of getting a mortgage for black applicants. This finding prompted considerable debate and discussion. See LAD in 1998 for an overview. Here I examined this question. Using the tree-based estimator described in the previous section, the data consists of 2,380 observations of 12 predictors, one of which was race. Figure 5 shows a conditional, so this tree, figure 5, shows a conditional tree estimated using the R package party, or you might use party kit. The tree fits pretty well, misclassifying 228 out of the 2,380 observations for an error rate of 9.6. By comparison, a simple logistic regression does slightly better, misclassifying 225 of the 2,380 observations, leading to an error rate of 9.5. As you can see in figure 5, the most significant variable is denied mortgage insurance. This variable alone explains much of the variation in the data. The race variable black shows up far down the tree and seems to be relatively unimportant. Again, and when we look here, it does seem to be further along the tree. It seems to be more peripheral as a key factor. The most significant factor overall determining very starkly were individuals successful in their mortgage application or not. Insurance seems to be quite a good predictor. Black here, race, seems to be less important, but what we may find also is that these other variables are correlated, that we cannot rule out the likelihood, or some likelihood, that black and not being black may actually coincide or correlate strongly with these other factors. Okay, so again, it may appear trivial here. To address that, Halvarian does a smaller table, smaller C3, and if again we plot and then we turn the plot off, graphs off, and then if we take a smaller data frame where we just examine the NI in relationship to denied mortgage insurance and black, so that's a much simpler relationship, and then we set that out as an object small fit, and then we plot the small fit. We can see here when examined through in this context, black looks to be a lot more significant, right, in terms of determining whether the individual's chances, probability of getting the mortgage approval true if you're black, it would appear your chances of being rejected or denied were much more significant than if you were any other race. Okay, so again, we should, following in line with Halvarian's suggestion here, maybe examine this through the rubric of the Logut model. And I follow, in the rest of this video, I will address that. And I'll use material from this textbook, so I can use this hyperlink. We'll just take a quick look. And this is the Introduction to Econometrics with R. And it comes up as a HTML. And again, we have the authors here. And then there is some text. So there's a binary choice model. I think it's chapter 13. Not chapter 13. Time series. Dynamic. Additional. Let me just see. Instrumental. Binary. Okay. So binary regression. So regression with binary dependent variable. This chapter we discuss simple class regression models that aim to explain a limited dependent variable. In particular, we consider models where the dependent variable is binary, and we will see that in such models the regression function can be interpreted as a conditional probability function of the binary variable. Okay, now I took snippets of code from this. They address the same issue here. In fact, the HMDA data, right? So that's actually convenient, but they used a slightly different data set. They used AER, that library, and then they have this capital H MDA. So some of the headings here are different compared to what's in Variant, but I'm going to try replicate using the Halvarian data set, replicate the results that are here and say a few things in terms of how we might understand black as being a factor in determining whether the mortgage were approved or denied, and also how linear regression compares to a Logut model. So let's just go back to R. Okay, so we again convert deny to numerical values. So before, if we look at all, the deny was yes, no, or yes. If we come back here and run that again, and then examine all, we can see then that this column now is a series of zeros and ones, not yes and no, but a series of zeros and ones. Okay, so we need that for our binary choice model. And then we can run a linear regression where we regress very simply the ratio of total monthly debt payment to total monthly income onto whether the mortgage was denied or not. And then we can print out that the coefficients, and it would appear that the higher DIR is, the more likely it is to deny the mortgage. Okay, so let's just plot that and look at that for a moment. And so we set out a series of zeros and ones. Was it not denied or denied? One denotes a yes, denied. And we can run and put in lines here capturing, linking up all our data points of zeros and ones. We can put in some text. Mortgage denied, mortgage approved. And you can see using the linear regression model, the ABLINE based on the D9 mod 1, which was the object we created in the linear regression, that we have a linear pattern here. And it's useful, but then it exceeds 1 over when the PI ratio, in fact this should be DI. Okay, so I've went back and changed that, and the way I changed that was by, instead of having the PI ratio here, XLab, I just changed to DIR. Okay, so you can see the output here is that if the DIR, if the ratio of monthly debt payments to total monthly income increases, then we're predicting here that the chances of the mortgage being denied increases, but we're not bounded by 1, which we would prefer, and down here we're not bounded by 0. We actually have negative probabilities, which are basically impossible, and that's something that means that the this type of model is not terribly appropriate, but can be useful just to demonstrate or to signal the sign. Okay, so we can develop another model, a little bit more complex now, run a regression model where we try to explain the dependent variable, again with the ratio of total monthly debt payments to total monthly income and black, and our data is equal to all, and let's just run that model and get our output, and you can see that again it's positive DIR. The higher this payment, the more likely it is that we will be rejected. But also if you are black, we can see here there are marginal effects that are positive in the sense that if an individual is black, the chances of the mortgage being denied are greater. Right? In each instance, the t-values seem to be greater than 2, which tends to denote that we would have some degree of statistical confidence that these variables are statistically significant from 0. Again, if we're to do this with a logit model, and it just purely explain the link in the dependent variable, which is a 1, 0, and the explanatory variable is just purely ratio of monthly debt payment to total monthly income, and run that logit logistic regression and then plot the outcome. Again, we're going through the same steps as before, and then we set out the model fit with the single variable. Notice the key advantage of the logit model is that it's bounded by 1 and 0. So we don't have a negative range, we don't have a positive range. And again, we can do that with more variables. We're interested to see, do we have positive values for DIR and black? Yes, we do, both indicating the higher that monthly debt payment to total income, the more likely it is that the mortgage will be denied. Also, if you're black, and it seems to be statistically significant, the more likely we are to be denied. So that seems to provide some strong evidence that race is a key factor. And then we can make a model prediction based on is the individual black, yes or no, and we in the same model, keep the ratio of monthly debt payments to total monthly income constant at 0.3, and we can make the predictions. And if it's model 1, right, where the individual is not black or white or some other race other than black, then the likelihood of a mortgage being denied is only 7%. But if the individual is black, when DIR is 0.3, then it becomes 22%, and then we can estimate the difference. The difference then in this static type analysis, an individual who is black has a 14% increased chance of their mortgage application being rejected. We haven't taken into account the other variables. Now, in both instances, obviously, the logit logistic model offers something. One of the key benefits of the ctree is that this type of machine learning is a very useful way to visualize the decision process. It provides us with some kind of intuition as regards what's happening. It sets out the key variables, and then we're able to partition along certain criteria. That actually could be very convenient if we're trying to model the process along which mortgages are accepted or rejected. And this whole process gives us some idea how machine learning can be operationalized. Again, that's of some consequence. It does tend to underemphasize perhaps the significance of being black, but again, black could be highly correlated with these other factors, and maybe it's being drowned out as a result. So again, very good a useful type of analysis, lots of intuition, good visualization.